Welcome back to this session. This session will give more definitions related to functions of complex variables. So our next definition So I want to define what we mean by a single valued and multi-valued function. So let's start by defining what we mean by a single valued function. So we say, if a function has only one value, for a given value of z, then it is a single valued function. For example, if we have a function f of z given by z squared. So any value of z you put in this function, you just get a single value. So that's what defines a single valued function. And then let's define what we mean by a multi-valued function. So if a function has more than one value, it is known as multi-valued function. So a function that has more than one value is called multi-valued function. E.g., if you define f of z by z raised power half, or simply the square root of z, then we have two values, plus and minus. Next definition, let's define what we call limit of a function. Now, a function f of z is said to have a limit L if for a given epsilon greater than 0. So let's say a function f of z is said to have a limit L at a point z equals to z naught if for a given an arbitrary constant, an arbitrary chosen positive number epsilon, they exist a positive number delta such that the absolute value of f of z minus L is less than this number epsilon whenever z minus z naught is less than this number delta. And we write as lim f of z, or limit of f of z, as z approaches z naught is given by the number L. So that's how we define limit of a function f of z of complex variable. Now let's define continuity. When we say that a function f of z is continuous. So function f of z is said to be continuous at a point z equals to z naught if for a given an arbitrary positive number epsilon, they exist a positive number delta such that if you take the difference between f of z minus L is less than epsilon for z minus z naught less than delta, i.e. a function is continuous at a point, actually this is the mostly used definition for continuity, at a point z equals to z naught if a f of z naught exists, or simply to say f of z naught is defined, and then b limit as z approaches z naught of f of z is the same as the value of f of z at z naught. So actually, this is the most preferred definition for continuity, that a function f of z is continuous at a point z equals to z naught if these two properties are satisfied, f of z naught exists, and the limit of the function as z approaches z naught is the same as the value of the function at the point z naught. Number 4, let's define what we call multiple points. So we say if an equation is satisfied by more than one value, of the variable in the given range, then the point is called a multiple point of the arc. And then next definition is what we call Jordan curve or Jordan arc. So that's number 5. Jordan arc. So a continuous arc without multiple points is called a Jordan arc. And then number 6, let's define what we call regular arc. So if the derivatives of the given function are also continuous, in the given range, then the arc is called a regular arc. So if the derivatives of the given function are also continuous, then we call that arc a regular arc. Number 7, contour. So contour is a Jordan curve. A Jordan curve consisting of continuous chain of a finite number of of regular arcs. So that's what we call a contour. And then we can say the contour is called or is said to be closed if the starting point A of the arc coincides with the end endpoint B of the last arc. The contour is said to be closed if the starting point A of the arc coincides with the end point of B of the last arc. And then number 8, the last one in this session, we define what we call zeros of analytic function. Zeros of an analytic function. So the value of Z the value of Z for which the analytic function f of Z becomes 0 is said to be the 0 of f of Z, e.g. zeros of Z squared minus 3Z plus 2 are Z equals to 1 and Z equals to 2. That means that when you put Z equals to 1 or Z equals to 2 into this function, you get 0. And then number 2, zeros of the function cos Z are or is plus or minus 2n minus 1 times pi over 2, where n runs from 1, 2, 3, etc. So in the next session, we give more definitions related to functions of several functions of complex variable. Thank you.